Special thanks goes to our gold sponsor, Accenture.
Yeah, this talk is about F# to an extent. As you might glean from the title, it's not necessarily trying to pitch F# as an alternative to Reason or OCaml or anything like that, or it's not even trying to come up with an alternative to Buckle script. But I guess given the possibilities with what you could do with F#, it might be possible to do something similar in the future. A little bit about me to get started. I live in Seattle, USA. I've been doing quite a bit of React Native and React for the last 3 to 4 years, but additionally, and before that, I did a lot of C# and F#. And so when Reason first was announced and I started looking at the syntax and the history and stuff like that, it had quite a bit of appeal based on the combination of those two things. And then you might have seen my conference photo. I do have a couple of pugs. I don't know, nobody had dog photos yet, but here you go. To get started with F#, a little bit about the origin story. You have to go back as far as when the .NET framework was introduced, which was a little while ago now. So when the .NET framework was introduced, it was kind of an attempt by Microsoft to get further entrenched in the enterprise, compete against Java, which had started to kind of take over to an extent. And one of the primary features of the .NET framework was the ability to have any language that was designed using the .NET framework to be able to compile down to MSIL, or Microsoft Intermediate Language. And the Microsoft Intermediate Language was kind of like the lowest level human readable language that you could get down to before you start getting further or lower level. And so when it first came out, there were languages like C# and VB.NET, and these were kind of evolutions from their predecessors like C++ or VB if you were doing VB forms ever. And then people came out with versions that could run on Windows on the .NET framework, like IronPython and Haskell.NET. And then fast forward a few years, it was announced that F# was going to start being included with some of the Microsoft tooling, like Visual Studio and so forth. And F# was a project that had come out of Microsoft Research, which is based in Cambridge, and that was designed by Don Syme. And fast forward, 10 years after that, the language evolved and so forth. But now, as of version 3, it was open sourced, and now it's maintained by the F# Foundation, and you can run it on Windows and Mac and Linux and so forth. And it's completely open source, and you can you can contribute and not have to worry about interoperability with Windows or like Microsoft licensing or anything. So that might have held it back when F# first got started, but now it's as open as any other language. Its relationship to OCaml, you could probably just describe it as like a cousin relationship, not dissimilar to Reason. When it first came out, it was a very close port to OCaml outside of the importing the different standard libraries and so forth. Like the language was almost verbatim because you're trying to run OCaml on Windows essentially. And then the language evolved to an extent, and the format of F# that came out initially was kind of labeled the verbose syntax. And like I said, it was kind of closely mirrored OCaml. And then they announced the light syntax, which reduced the amount of tokens and so forth, like if, begin, and stuff that existed in OCaml, but and then relied more on indentation and white space. But so it was a little bit more terse, but at the expense of some of the tokens. And then just a side note that the light syntax was helped to come to fruition, and it was designed by Simon Marlowe, who helped design the Glasgow Haskell compiler, if you're familiar with Haskell. And so we'll just take a quick look at F# if you haven't really seen it before. If you're seeing it for the first time, you can kind of tell it's like pretty similar to OCaml or the Reason that you've been doing for the last either few days or few months. You can import modules using the open keyword. You bind functions such as getQuestion And then a little bit different, we have the entry point attribute. Attributes are a .NET framework feature, I guess. It's used to use metadata to describe either functions or I don't know, basically anything. Anything in the .NET framework can be annotated with an attribute. But in this case, if we're running a standalone program that would use a main function, we would decorate it with the entry point. You can see arrays are defined very similarly, and then you have the forward pipe operator to map and then iterate through the previous results, and then similar to Reason or OCaml, you return with the last statement in a function, and that's, I mean, F# in a nutshell. So if you wanted to get started, it's a lot easier than it might have been on any platform than it would have been a few years ago. If you're familiar with Homebrew, which most people probably use these days, you can run it on a Mac to install the .NET CLI, which includes .NET Core. .NET Core is Microsoft's attempt to make the .NET framework portable into Mac and Linux. The latest version of the .NET Core is 2.0, or I guess 2.1 now, and it encompasses like all the different base class libraries that have been around for, I don't know, about a decade or so you don't have to futz around with small little libraries that may or may not be stable like you could in other ecosystems. And then within the last year or so, Core RT allows you to target .NET Core libraries or programs towards any kind of additional platform, including Linux, Mac, or OS X. So you can have standalone applications, kind of like you would with Go or even OCaml, I suppose. For practical matters, more and more code is running in the cloud these days, specifically as functions as a service. So F# has first-class support for all the three major vendors, Azure, of course, being Microsoft, Google Cloud Functions, and AWS Lambda. Here's an example of how you could create a AWS Lambda function using F#, so you can just download the template. This is also a package manager interface, and then you can instantiate a new cloud function specifying the language, but also your different AWS parameters, like your region and the profile to use. And then you can deploy it with one further command after you make the changes that you want. So deploy function and the name of the function. So pretty easy to get started as opposed to having to use technology like serverless or something like that. The template that is used here just generates this default function. You can kind of tell at a glance, it's just regular F#. You have labeled parameters to this function. So F# and C#, the code in large part is interoperable. You can import C# libraries into F# and sometimes vice versa, but you can kind of see some relics from that. In this case, we have a member function as opposed to a pure function, but you can see we're returning the matched input in either an empty string if we don't get a string, or just two upper. So this will get deployed to AWS Lambda. Now to talk a little bit about special features, which I think might be of interest to people who aren't as familiar with F#. That I don't think they exist in OCaml or maybe even any other language, but they can really help with productivity. First of which is units of measure. So I mean, F# is very similar to OCaml, where you have strongly typed or very strong types, but it's also using inference, so you don't have to type a lot of redundant stuff. But units of measure go like a step ahead of like using regular floats or something. You can annotate them with an additional parameter. So if you're dealing with units of measure like meters, seconds, or even compound measurements, meters per second, and so forth, you can have compilation guarantees that if you're either trying to add or add two different time variables, like you couldn't accidentally add time to distance and it would break at compile time, but you could, for instance, divide one of these and get one of the other units of measure if it was applicable. So maybe something that could get into Reason in the not too distant future. Async workflows. These are pretty powerful. One of the advantages of using the .NET Framework and F# is you're able to address multi-core systems because you do get several threads, and if you're familiar with some of the latest async syntax in ES 6 or 7, you're familiar with like the async await sugar. This is very similar, kind of derived from that pattern, and so you can use the async block and use like a web client that will return a string asynchronously, but if you specify the bang after the let keyword, then that will essentially be the equivalent of a wait if you're used to the JavaScript. And then down here you can specify the URL and then pipe it to fetch HTML async, which will actually trigger, and then you can run it either synchronously with parallel. You can change these together. It's pretty powerful, so something to keep in mind. And then, in my opinion, the coolest feature of F#, and this is something that has been around for 2 or 3 years, is the notion of type providers. Like if you're familiar with, functional programming kind of uses the paradigm of data as code, and this is kind of like data as code on steroids because it allows you to use external data sources, which can then ultimately be part of your code. So here's a kind of a simple example using a JSON provider. There's also HTML provider, XML provider, and so forth. And the first line, we're priming the JSON provider with just example JSON that we expect to be used. And then here we're parsing another set of JSON that conforms to that format. And we have the simple, this parse value gets assigned, bound to simple. And then if you were using IntelliSense or something, you automatically get age and name and so forth, and this is just a convention of .NET Framework or F# to have these capitalized properties. But probably the coolest one, or way that you could use this, is you could point the JSON type provider at a remote URL, and let's see if this works. Okay, yeah, the video is working, and you can like point it at a REST endpoint that, as opposed to digging into like a Swagger doc or something like that, you can like rely on the compiler to remotely fetch your external data source and provide types in memory, and then you can use IntelliSense to start using those types automatically. So you can start changing your data source and then rely on your compiler to have those types automatically updated. Oh, and if you're working on your code on the plane, you wouldn't want to use this, so you probably want to copy a snippet of the JSON and use that locally if you're using that kind of scenario. So if this kind of stuff appeals to you and you want to learn more, the first resource I would check out is fsharp.org, which is the official site of the F# Foundation. The site that I use to kind of learn F#, which has been around since at least 2012, is F# for Fun and Profit. INI.io has some cool plugins that interface with the F# compiler service, which are used to do type providers and so forth, and that has integrations with VS Code and so forth. A couple books here at the end are F# 4.0 design patterns and domain modeling made functional. So that's about it. Thank you.